Howdy, I'm going to talk about the exercise where you needed to design a network that will support 8 desktops, 1 server, and 1 printer in a 24 by 40 foot room using specific switches and pre-connectorized patch cables. The first thing you need to do here is determine the scale of your printout, whatever you printed it out on, and then to lay out the desktops on it. I held up my ruler to the diagram and I found out on my diagram it was 25 centimeters wide, and so that means that the scale of my diagram as printed out has 1.6 feet per centimeter that I measure on the diagram. I then laid out the desktops, and on the diagram I end up with about 7 feet per person, so that's actually plenty of space. And there's space in the corner there for the printer and the server. Now, this is the actual physical design of the workspace. What I want to talk about really quickly is the logical design and which logical designs worked and which ones didn't. All right, the first logical design here is one that would not work. A server is a host, and it's not a networking device. It is possible, I'm sure some of you already know this, it is possible to put multiple network cards in a server, and then in theory it could serve as a router, etc. But this is not the way a normal person would make this network work. You want everything to be connected via switches. The next logical design is actually, if you notice, it's in a ring. That is, we have 4 switches here, and they're connected sort of around in a circle to each other. This would actually work, but it is not optimal, because what actually ends up happening is in Ethernet, there's only one path allowed between hosts. So the switches in this case will automatically shut off one of the links. That's kind of an advanced topic, and we'll get to that later in class. The next logical design is one that would also work, but it's not optimal. Normally people would call this a daisy chain of switches, and you'll notice here we have one set of desktops connected to the first switch, so we got 4 connected to the first. We connect 3 to the second, 1 desktop to the third with the server and the printer. Now, because the server and the printer are going to be the most commonly used devices on the network, it causes a bottleneck, especially on the trunk lines between that very first and the very second switch. And again, in some ways, to the second and third. So what you want to do is actually put the printer and the server at what we would call the core of the network. And that gives us this third logical design, which most people would consider the best practice. In this situation, you'll notice here the main network resources are at the core. You might notice here also, if we have an internet connection, we can connect it at that core too. And then we have what we would call sort of a second level of switches, which we in class we'll call them workgroup switches. That's where you connect the desktops. This network topology is called an extended star or a hierarchy. Now, once we've designed this logically, we can go through and actually say, what do we need in terms of equipment? At this point, I know I'm going to need 3 switches, and I'm going to need 12 cables. There's 8 connected to the desktops, 1 for the printer, 1 for the server. That makes 10. And then I need 2 cables that connect the switches together. Now, the final thing I need to do is an actual physical design. What I have on this picture is it's actually the physical layout of the desktops, but with the border of the room removed. So it's the same as that first diagram, just with the outlines of the walls removed. What I need to do now is measure how long the distances are. If I measure the distance from the furthest away desktop to a switch, the longest distance is 14 centimeters on my ruler. If you look down at the bottom, you can see, going from number 6 to number 20, that's a nice 14 centimeter distance. That ends up being 22.4 feet when I convert my scale. And what I'm going to do is allow some extra distance on my longest cable to allow the cable to sort of hang down to the floor. If I did something exactly 22.4 feet, it actually wouldn't work because I need to allow even a little bit of distance for the cable to plug into the back of the computer and then again into the switch. So just a few inches, no matter what, needs to be allowed. And normally you're going to allow several feet just to make it work better. So once I once I allow my 22.4 feet plus the 6 feet, that ends up being my next highest, the next highest level of feet in terms of what I can actually buy is a 30-foot patch cable, and I'm going to buy 5 of those. If I look at my diagram here, that's going to take care of the 4 workstations that are furthest away from their switch, and then the distance between the switch on the bottom of my diagram and the switch that's the core switch. So that trunk line there will also be one of those 30-foot patch cables. Knowing that, I can go to the next set of the shorter distance and say, okay, how much more do I need here? If I measure that distance, it ends up being on my diagram about 5 centimeters. You can see it on the bottom. It's about between the 15 and the 20. That's an 8-foot distance. I'm also going to add 6 feet. The patch cable I would buy then is the 14-foot cable, and I'm going to buy again 5 of those. So that will cover the next 4 desktops and then the trunk line between the top switch and the next switch there. So that uses up 5 of those cables. I don't actually need that many more cables. I only really need 2 more, but I still am going to you got to buy them in packs of 5. So if you actually look at these distances here, the printer and the server will be almost right next to the switch. I might be able to get away with a 3-foot distance, but I'm going to go ahead here just for convenience sake and knowing I might need a little flexibility. So I'm going to buy 5 of the 7-foot switches. Now right here I'm going to stop. You can determine the prices yourself. Normally I would expect to see this in an Excel spreadsheet or at least in a little table that shows me I'm going to buy, yes, 3 5-port switches. I'm going to buy 5 of the 30-foot, 5 of the 14-foot, and 5 of the 7-foot, and then I would need a total materials cost. And then I'm done, and I have a complete proposal, and it's ready to submit to someone.